Okay, we're going to continue working through your study guide. I'm on page 23 now, and the rest of the problems we're looking at are all going to be solving problems. So if I start with number 19 here, we're going to solve this equation. I want the term that has the exponent by itself. So we need to get the x by itself. That means this 2 needs to divide off to the other side. So I would have x to the 2/3 equals 25. And now when I have an exponent, I want to raise this to the reciprocal power. And whatever I do to one side, I'll do to the other. The reason I want to raise this to reciprocal power is because when I have a power to a power, I multiply. 2/3 times 3/2 would give me 6/6, which is just 1. So now I just have x, or x to the first, and I need to figure out what's 25 to the 3/2 power. Now remember, fractional exponents I can write as a root. So this would be the square root of 25 cubed. The square root of 25 is 5. 5 cubed would be 125. For number 20, this time the number and the variable are in parentheses with the exponent on the outside. So I don't need to divide the 4 to the other side first. In fact, you should not divide the 4 to the other side first because it's also raised to this power. I want to go straight to taking this to the reciprocal exponent. So I'm going to take this to the 5/7 power. So my exponents would reduce each other here, and I've got 4x. And then 128 to the 5/7 power. So that would be the 7th root of 128 to the 5th power. The 7th root of 128 is 2, and 2 to the 5th is 32. Now I'm going to divide both sides by 4, and I get x to be 8. Don't forget to check your work either using a graph both sides and look where they intersect, or by taking your value and plugging it back in for x. For number 21, I've got a square root this time. I want to get the root by itself. So what I see here on the left is that I only have the root. So I've got the root part by itself. Now I'm going to undo it by squaring. Whatever I do to one side, I have to do to the other side as well. So the square and the square root would reduce each other here, and I have 4 minus x equals 4 minus x squared. So that means I've got 4 minus x times 4 minus x, and I need to distribute here. So that would be 16 minus 4x minus 4x plus x squared. I'm going to move everything to the same side, rewrite this in standard form. Since I've got x squared and x, my next step in this process to solve is going to be to factor. So that's why I want everything on the same side and in standard form. So this would be x squared. That would be minus 8x minus 7x plus 12. So when I factor this, I get x minus 3 times x minus 4. And for my solutions, I would get 3 and 4. Moving on to number 22. Again, I have a root here. I've got the root all by itself on the left side, so I get to go ahead and square. So this would be x plus 9 equals 4 squared, which is 16. Move the 9 to the other side, so I can get x by itself, and I get x to be 7. Number 23, I've got an exponent again. I'm going to go ahead and get the thing with the exponent by itself. So that means I need to divide both sides by 7. So I have x to be 4/6 equals 112 divided by 7 would be 16. Now I'm going to take a reciprocal power on both sides, 6/4. So I'm left with just x on the left-hand side. Here I'm asking what's the 4th root of 16? And then take it to the 6th power. The 4th root of 16 is 2. 2 to the 6th would be 64. So x is 64. Number 24, again, I have something with an exponent. So I want to get the thing with the exponent by itself. That means this 20 needs to move to the other side. So I've got x plus 2 to the 3/2 power equals 64. And now I'm going to raise both sides to the reciprocal exponent, so to the 2/3 power. So I have x plus 2 equals, this would be the cube root of 64, then squared. The cube root of 64 is 4, and 4 squared is 16. Now, one more step to get x by itself. I'm going to subtract 2 from both sides, and I get x to be 14. Number 25, we've got a root here again. So we actually have a root and an exponent. I'm going to deal with this root first. To get rid of that fifth root, I would need to raise this to the fifth power. So I also have to raise the 4 to the fifth power. So those are gone. And I've got x squared equals 4 to the fifth. 4 to the fifth power is 1024. And then to get rid of the square, I need to take both sides to the 1/2 power or square root each of them. So this would give me x equals, here's where we have to be careful. Since we took a square root here, this would be plus or minus 32. Anytime I take an even root, always plus or minus for those solutions. If I check both positive and negative 32 on my graph, or by plugging those in, I would get the same value on the left as on the right. So both of those are solutions. Number 26, I've got a plus 10 to the 1/3 power. I've got something with an exponent all by itself, so I can go ahead and take that reciprocal exponent. Since this is the 1/3 power, my reciprocal exponent would be 3/1 or just 3. So we're cubing both sides. So I get a plus 10 equals 3 cubed, which is 27. And to get a by itself, I'll subtract 10 from both sides, and I get a to be 17. Number 27 is kind of tricky because I've got multiple roots and then I've got something that's not under a root. That's okay. I'm still going to approach it the same way. So if I only had one root, I want that on a side by itself. Since I have multiple roots here, I want to split them up. And then I'll square each side. Now remember, we're squaring the whole side, not the individual terms. When I square on the left, I'm left with just x plus 39. When I square on the right, I'm actually going to have to write this twice and distribute. Now this looks a little funky because we're distributing something that has a square root in it. That's okay. We follow exactly the same procedures. So root x times root x would be root x squared. The square and the square root undo each other, so we just get x there. And then plus 3 root x plus 3 root x plus 9. And now let's go ahead and combine like terms. Remember, this is an x. The square and the square root undid each other. So on the left, I still have x plus 39. And then on the right, I've got x plus, that would be 6 root x plus 9. And now I'm going to go ahead and move my x's together. When I move my x's together, since I have x and x on both sides, it actually doesn't matter which one I move because I'm going to end up with no more x's. Right? So if I move this one by subtracting, now that one's gone as well. Then I'm going to go ahead and move this 9 to the other side. So this is my only term remaining that will have an x. I want it by itself. Now this looks like a square root problem. So I want to get the thing with the root by itself. So I'm going to divide that 6 to the other side. And I get 5 equals the square root of x. So now we'll square both sides to get rid of the root. And I get 25 for x. For number 28, this time we have a cube root, only one of them, and it's by itself. So we're going to go ahead and undo that root by cubing both sides. This will give me b minus 2 equals 2 cubed, which is 8. Add 2 to both sides to get b by itself, and we get b to be 10. For number 29, again, I've got a root here. This is the only root in the problem, and it's by itself on the left side, so I can go ahead and square both sides. This gives me x squared minus 12 equals 2 squared, which is 4. This is back to a quadratic method of solving from last semester. I'm going to get the squared thing by itself. So that means I want to move this 12 to the other side, and I get x squared equals 15. Now I'm going to take a square root to get rid of the square, and I get x to be plus or minus 4. So I took the square root, plus or minus. Now for number 30. Again, I've got a root. It's on a side by itself. So I'm going to square both sides to get rid of that root. This 2x minus 1, I'll have to distribute out. So when I multiply, I would have 4x squared minus 2x minus 2x plus 1. And since I have x squared and x terms, I want to move everything to the same side so that I can factor. I'm going to subtract 8, and I'm going to add x. So I get 4x squared minus 3x minus 7 equals 0. I want to factor this using AC method, so I'll go ahead and work through those steps here. 4 times negative 7 gives me negative 28. I want factors of negative 28 that adds a negative 3. Well, that would be negative 7 times 4. So this would be 4x squared. We'll do plus 4x minus 7x minus 7. And then we use our grouping strategy here. My GCF for the first group is 4x. That leaves me with x plus 1. My GCF for the second group is negative 7. That leaves me with x plus 1. So my factored form would be x plus 1 times 4x minus 7. So my solutions then would be negative 1 and 7 over 4. Now I want to show you on this one how we could check our solution by graphing. So if I check this on a graph, let me go ahead and find a graph page here, open a new one up. I'm going to graph the left-hand side, 2x minus 1. And then I'm going to hit the tab key and graph the right-hand side. So I've got the square root of 8 minus x. Now I'm going to look for where they intersect. So I can see an intersection here. I'm expecting, based on my work, 2 solutions, one at negative 1 and one at 7 over 4. If I look at negative 1, I can see there's not going to be an intersection there. My graphs are at 2 different points for negative 1. So this is what we would call an extraneous solution. We saw those in our rationals unit as well. And then if I double check my solution here, menu, analyze graph, find that intersection, and I click on either side, I get 1.75. That's the same as 7 over 4. So this would be our only real solution here. If I go back and double check another one of my problems, so let's go back and check number 29. Same idea here. I'm gonna go ahead and get rid of my graphs that are there and add these new ones. Square root of x squared minus 12. And then I'm going to graph 2. I can see 2 intersection points there. And if I want to find their exact location, menu, analyze graph, intersection, I have to find them one at a time, but I can certainly find them. There's negative 4, and then menu, analyze graph, intersection. There's positive 4. So both of those are solutions for it. Okay. You can also check by plugging in your values for x into your function. That would work too. So those are the solving problems from your review. If you have questions on any of the problems in your review, please make sure you talk to your teacher and ask your questions before our